Okay, hi guys. So in this lecture, we'll be starting off with Clemenson reduction. Okay, so let me put down the heading first. So we have Clemenson reduction. Okay, so suppose we have something like this, and we are reacting it with zinc amalgam and HCl, or you can also use sodium Hg again in presence of HCl, and we will have simple cyclohexane ring. Okay, now next we'll see Wolff-Kishner reduction. Wolff-Kishner reduction. Here we have something like, again we have a ketone. Okay, on this we actually use NH2 and second we use KOH and we heat it. So as a result we get cyclohexane ring. And the third example is we have something like again a ketone. Okay, we have to use magnesium amalgam, presence of water, and second we have aluminum amalgam in presence of again water. Okay, so what we will get is a vicinal dihalide or a pinacol. Okay, this is vicinal dihalide. This is also called this is pinacol and also called vicinal dihalide. Vicinal diol, sorry, not halide. Okay, so what is the mechanism of Clemenson reduction? We'll look into that. So mechanism of Clemenson reduction. Okay, so first of all, this is also correct up to a certain extent. It is also uncertain mechanism. Okay, so researchers are still on to this mechanism and finding the mystery behind this. Okay, so what we have is something like a ketone, and what we have is, let's suppose, zinc amalgam. Okay, so what the zinc does is, zinc actually oxidizes itself into Zn plus and E minus. Okay, so this E minus goes and attack onto this carbon atom, and as a result carbon gets a free radical and oxygen gets a negative charge on itself. This oxygen actually attacks on HCl to get OH free radical here. Okay, and then zinc again loses one electron to get to Zn plus 2 state, and this electron again attacks on this free radical. Okay, to convert it into itself into a negative charge here, which again on reaction with HCl, this negative charge hence formed would be actually attacking on again H plus to form something like this product. Okay, and H is also there. Okay, now what will happen is, this formed compound here would actually again undergo reaction with HCl. Okay, and this time the lone pairs of oxygen atom will actually attack on the hydrogen atom to form a positive charge on the on the middle carbon atom, and water molecule would be released hence. And then again the zinc will convert itself into Zn plus 2 and 2 electrons. Okay, these 2 electrons will again attack on this carbocation to form a negative charge here. Okay, and this negative charge again reacts with HCl to extract H plus from Cl minus, and as a result this compound would be finally formed. Okay, so how many moles of HCl were actually consumed? 1, 2, 3 and 4. So 4 moles of HCl consumed. Okay, now let us discuss about the characteristics of the Clemenson reduction. So we have characteristics of Clemenson reduction. Here we have the first point as the product is obtained in acidic medium. Okay, product is obtained in acidic medium. As you can see, the moles of HCl is being used. Okay, confirms that product hence formed is in acidic medium. Okay, so sodium or zinc amalgam can be used in Clemenson reduction. Okay, sodium or zinc amalgam can be used in Clemenson reduction. Okay, third point is magnesium or aluminium amalgam is used in pinnacle formation. Okay, pinnacle formation or in vicinal diol formation. Okay, now actually let us look at the general reaction. Suppose I have something like this compound, a ketone, and this is reacting with NH2Z. So this will form a compound, or rather I should write H2 here and here. Okay, so this actually on heating in acidic medium, the water molecule gets the water molecules get actually disintegrated from the two compounds, resulting in the addition of double bond over carbon atom and nitrogen atom. So as a result, you will be getting something like this. Okay, minus H2, or you can say H2 in the product side. Okay, so how this actually works behind the scenes is we have something like we are doing it in acidic medium, right? So this in contact with H plus, the O donates its lone pair to the H plus and will get something like O plus H, which on again reacting with NH2Z, the N will give its lone pair to this positively charged carbocation, partially positively charged carbocation. So we'll have something like OH here, and N will get a positive charge hence, and this would be the case, right? So what will happen next is again this H plus would be recouped into the reaction, and again we'll get something like OH and NH plus NHZ plus NZ plus H plus is recouped back into the reaction. Then OH, the oxygen atom from the OH again attaches H towards itself, and we have something like this. We get something like this. This get detached. The lone pair again gets into the double bond between itself, the nitrogen atom and the carbon atom. Will get something like N plus HZ plus H2. Okay, again this H which was used up in the reaction will again be recouped because of taking back of lone pair taking back of bond pair from H towards itself. The nitrogen atom will do this and will have something like NZ. Okay, so in short way we could have directly written this: the water molecule was removed and NZ was formed. This compound with double bonded with NZ. Okay, so we have to also see some of the major reactions or major examples that will be coming up in the next lecture. So till then, good luck and goodbye.